This lesson is on solving one-step equations. So that's all well and good to be able to determine if a solution or if a value is a solution to an equation, but a lot of that's just guess and check. And so instead, we have some steps that we can follow in order to actually solve the equation and find the correct answer or answers to find the entire solution set. So what I want us to think about here when we're solving an equation is I want you to sort of think about it as a puzzle. So the big idea here is to think about it as a maze or a puzzle, and we're going to start at the end and work backwards. And so what I mean by that is you're going to find out where that variable is in the question, and then you're going to start by undoing all of the operations starting furthest away from the variable. And we're going to work on that together so that you understand what I mean. Now again, these are going to be one-step equations. There's just going to be one thing that we have to undo to find the answer. And as we continue through, again, we're going to start with the x and start furthest away, but on the same side of the equal sign. I did throw in here the properties of equality because a lot of times your online platform will say use the subtraction property of equality or addition property of equality. That just means that if you add something to one side, you have to add something to the other side, or subtract from one side, you subtract to the other side. So that's what we're going to be doing. We're going to undo operations, and then whatever we undo on one side, we have to make sure we do it on the other side as well. So let's work through these questions together so you understand what I'm talking about. First of all, I typically draw a wall here where the equal sign is, because when I do that, it reminds me that something is happening on each side of the wall. So here, I'm starting with this x, and I'm looking at the operation that has been done to x, which is that it's been added to 12. And so to get rid of a positive 12, I have to subtract 12. Now I'm going to subtract 12 here, and notice I've lined it up underneath the 12. I'm going to do the same thing over here, and it's very important that you have the same thing on each side of that wall. So on this side, notice I've only subtracted 12 once. I didn't write it underneath the x. 12 minus 12 is 0. It cancels out, and I just get x. And on the right side, I have 40 minus 12, which is 28. Now, whenever you finish an equation, and this can be one-step equations like this, or when we get into much more difficult equations, I can always plug that value back in and make sure that it does, in fact, equal out on each side, just like we did previously when we were checking solutions. So 12 plus 28 is 40, and 40 does equal 40. And so that's called doing a check. So we're just checking to see if our solution is actually correct. Let's look at the second one. Again, I'm going to draw my wall. I'm looking at x. The operation that has been done to x is to minus 5. The inverse operation or opposite of subtraction is addition. So I'm going to add 5 to each side. On this side, minus 5 and plus 5 is 0. They cancel out, and all I have left is x. On the right side, negative 11 plus 5, remember those are opposite signs, so I find the difference, which is 6, and give it the sign of the bigger number. And again, I can do my check. Negative 6 minus 5 equals negative 11, I hope. And then if I do, in fact, add negative 6 and negative 5, I get negative 11 equals negative 11, and so it worked. Last one here, I've got 4 equals w divided by 2.2. You don't have to have the variable on the left side of the equation. Quite often you'll see it there. If it freaks you out a little bit, you're welcome to do this and say, let's get rid of the 4 on this side and make it 4 on this side instead. But it's certainly not necessary for you to do that. This is w divided by 2.2, and to get rid of a divided by, I have to multiply. So what I'm going to do on this side is I'm going to take it times 2.2, oops, not 2.1, 2.2, and this side times 2.2. And it's okay that I wrote them a little bit differently. On this side, I wrote it as a fraction because if you have something as a numerator and a denominator, you can cancel them out. And now I just have w over 1, which is just w. On this side, I'm going to take 4 times 2.2, which is 8.8, and that should be my final answer. And then I can do my check. I can do 8.8 divided by 2.2. Equals 4, and hope that that works out, and if I divide, I do get 4 equals 4. So everything worked out. Let's do a couple more together. These get a little bit trickier, a couple of them. Over here, this is x times negative 1/2 equals 5/8. So you kind of have a choice here. This is negative 1/2 times x, so to undo multiplication we divide, but that would mean I'm dividing by a fraction, and that's typically not very much fun. So what I can do instead is I can think about this as negative x over 2, or x over negative 2, because this is a whole number, basically, so it's a numerator, so I can stick it on the top there. And if I think about it that way, then I can say, well, what if I just multiply by negative 2 over 1 and do that to both sides? And so what's going to happen here is my negative 2's cancel, I get x over 1, and that works out great. On this side, I'm going to go ahead and reduce this to 4 and to negative 1, because I took 2 into this value and 2 into this value. And then when I multiply, I get 5 times negative 1, which is negative 5, over 4 times 1, which is 4. And remember, we talked about the fact that you can leave it just like that. Again, you can do your check, negative 1/2 times negative 5/4, and hopefully we get 5/8. Here, I'm going to multiply negative 1 times negative 5 to get 5, 2 times 4 to get 8, and 5/8 does in fact check out, so we did okay. I threw the second one in here because a lot of people get confused with the minuses in front. Remember, if there's no number, it's a 1, and so in this case it's a negative 1. So now I'm going to divide by negative 1 on top and on bottom, or on the right and on the left. This side, the negative 1's cancel, and I just get x, and this side I get positive 4. And again, then I can throw that into my equation and check it out, and obviously negative 4 equals negative 4, and it checks out. Last one here, I'm going to divide by 5 because this is 5 times x, so I divide, that's the inverse operation, and I get x equals 7, and then 5 times 7 equals 35, and so it checks out. Try these on your own and then check to see how you did. For my first one, again, I've got 4/9 x. So now I need to think about how am I going to get rid of 4/9, so I have to divide by 4/9. And when we divide by a fraction, we multiply by the reciprocal, so this is the other way to do it. So if I take this side times 9/4, that's the reciprocal, remember that's flipping it over. And I take this side times 9/4. Notice on this side, my 4's cancel and my 9's cancel, and I just get 1 over 1 over 1 over 1, which is just basically x on the right side. On the left side, this one reduces to 3 and 1. This one reduces to 2 and 1. So I get 3 times 1 with that negative in there is negative 3, and 2 times 1 is 2. So that should be my final answer. For my second one here, I've got 6 plus x. I need to get rid of positive 6, so I'm going to subtract 6. And that gives me x equals negative 9. And on my last one, if I divide by negative 3, I just get negative 7/3. Typically, we're going to write that on the top, the negative on the top. And again, you can go through and do those checks yourself, but those should be your 3 solutions.